Welcome back to the Algebra 2 Structure and Methods textbook series. This lesson is written on Chapter 9, Section 1A, the distance formula. So today you're going to learn how to find the distance between any 2 points. Before you start the lesson, you should know how to simplify radical expressions and graph points in the coordinate plane. Let's get started. For our warm-up, let's simplify the following expressions. Pause the video and restart when you're ready to check your answers. I'll show the answers in 3, 2, 1, now. Okay, now, if you struggled with this, go back and review Chapter 1, Section 2, and let's begin our lesson on the distance formula. The correct notation for the distance between any 2 points, P and Q, is PQ. On a number line, this distance is the absolute value of the difference between their coordinates. In the diagram below, the length of PQ is -3 minus 2, or -2 minus 3, which equals 5. Now note, you can subtract the coordinates in any order because the absolute value of b minus a is equal to the absolute value of a minus b. Suppose we need to find the distance between 2 pairs of points. If you know how to do this, pause the video and try to find the distance between A and B and C and D and restart when you're ready. I'll show the answers in 3, 2, 1. Okay. Now, A and B lie on a horizontal line, so the distance between A and B is the difference in their x-coordinates, which is the absolute value of 4 minus -2, which equals 6. C and D lie on a vertical line, so the distance between C and D is the difference in their y-coordinates, which is the absolute value of 6 minus -1, which is 7. Now, suppose we want to generalize this as a formula. We have 2 points, P with coordinates x1, y1, and r with coordinates x2, y2. The horizontal line through P will intersect the vertical line through r at Q, which has the coordinates of x2 and y1. So P and Q lie on the same horizontal line, so the difference between them is the difference in their x-coordinates, which is x2 minus x1. R and Q lie on a vertical line, so the distance between them is the difference in their y-coordinates, which is y2 minus y1. Now we can use this formula to find a general formula for the distance between 2 points on a non-vertical line. Let's quickly review our friend, the Pythagorean theorem. We're going to need it for the distance formula. In a right triangle with hypotenuse C and legs A and B, we have the following relationship. C squared equals A squared plus B squared. And now let's use this to find the distance between 2 points on a non-vertical line. Okay, so now let's suppose we have 2 points again. We've got P1 and P2. Now these are not on a horizontal line and they're not on a vertical line. Now P1, P2 is the hypotenuse of a right triangle, and the points on the triangle are P1, P2, and the intersection of the vertical and horizontal lines, Q. Now Q is going to have the same x-coordinates as P2 because they're on the same vertical line, and the same y-coordinates as P1 because they're on the same horizontal line. So our coordinates of Q are x2 and y1. Therefore, the length of P1Q is x2 minus x1, absolute value, and the length of P2Q is the absolute value of y2 minus y1. Now we can use the Pythagorean theorem to form an equation, P1, P2 squared, right? Because we know that the legs squared, the sum of the legs squared equals the hypotenuse squared. So we have P1, P2, our hypotenuse squared, plus P1Q squared, 1 leg, plus P2Q squared, 1 leg. So now we're going to substitute our side lengths into our equation. We have our x2 minus x1 for P1Q and y2 minus y1 for P2Q. Then we rewrite it without the absolute value signs, and we take the square root of both sides. And this is the distance formula. So let's summarize it in a nice, neat little theorem. So we have just proven that the distance d between 2 points P1 and P2 is given by d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And note that the order of the coordinates can be switched because we're squaring the terms. Okay, in example 1, we need to find the distance between these 2 points, -2, -1, and 4, 3, -4, 3. Now, obviously I've already identified my coordinates. X1 is going to be -2, Y1 is -1, X2 is -4, and Y2 is 3. So next, I'm going to substitute these into the distance formula, and I'm going to simplify, and my answer is 2 square root of 5. Okay, so the hardest part is usually just identifying what the coordinates are. So you did a great job today. We only had one example, but I'm sure you'll get plenty more time to practice. Now that you know 2 ways to find the distance between 2 points, we have the Pythagorean theorem and we have the distance formula, turn to your classmate and answer the following question. Using the Pythagorean theorem to find the distance between 2 points has its limitations. Can you think of any? And I will see you in the next lesson.